Hello, my name is Derrick Mitchell. For the past 8 weeks, I've been working with Dr. Anderson's research group at the University of Toledo. Today, I am very excited to tell you about my experiment. Come on in. Throughout the 8 weeks, we have focused on a technique called SPME. SPME stands for solid phase microextraction. As you see, this is very small. SPME is nothing but a fiberglass that is very delicate and if poked feels like a hair strand. This technique is relatively new and was invented by Dr. Polish and his co-workers in the early 1990s. As I said, SPME is a relatively new technique. Things new about it is that it does not use all of the sample and is smaller. Capabilities of SPME are blood testing, checking for water impurities, and also potential drug analysis for steroids. As you see, the fiber is still golden. The coating on the fiber right now is called polyimide. What we do first is burn off a centimeter, which makes the fiber white. We begin this by going in and out the flame fast. We do this because if you go in too slowly, it can bend the fiber. Make sure the fiber burns. And make sure you turn off your fire. Now that you see the fiber is white, we're ready to begin coating. After this, we seal with butane and oxygen. You need a coating for SPME, because without a coating, anything you're trying to extract will slip right off the fiber. There are 4 main commercial coatings and a ton of mixtures. Most labs use ionic liquid. So right now I'm going to draw a monomer. This is your cation, and this is your anion. Ionic liquid is simply a salt with a melting point below 100 degrees Celsius. Notice the name ionic, which represents ionic bond, cation and anion, which is stronger than covalent bonds. In our lab, we use PILs. To polymerize, we use a compound called AIBN. AIBN helps the monomer become a polymer by attacking the double bond right there. When it attacks the double bond, it forms a long chain with pendulum shapes hanging off the double bond. PILs are way more reliable. Once this is attacked, it becomes a polymeric ionic liquid, or PIL. As we all know, 2 is better than 1. Ionic liquids are still used widely in laboratories, but PILs are better to use just because with ionic liquids you have to constantly recoat, which can harm your data. Once you have polymerized your monomer, you're ready to use a SPME fiber in our lab. As of right now, I'm set up in extraction. I'm putting in 15 mL of water and 20 microliters of my analyte. There are 2 types of extractions, direct immersion and headspace. In headspace, the fiber is not directly in the solution, in direct immersion it is. I put the 15 mL in and make sure I lose no water, because with loss of water, it can harm the procedural data and mess up my analyte. Now, I pipette 20 microliters of my analyte. After finished with this, I'm ready to extract. Now we're about to begin our extraction. We put the fiber in delicately so you don't break the fiber. And I once mentioned earlier direct immersion and headspace. For the data we're doing right now, we're actually going to do headspace. So you really can't see, but we're not going to put the fiber that we burnt off into the solution. Now we set this up, and we let it sit for an hour. While the fiber is in the vial, the analytes are in a sense jumping onto the fiber. And with the exposure to oxygen, you can lose analyte. So after the extraction is over in the hour, we hurry to the GC, put the fiber in the GC for 5 minutes, then take it out. You give the GC a little bit of time to determine the data, then you get your peaks. As I said, you have to hurry to the gas chromatography so you don't lose analyte. You put this in the GC for 5 minutes, take it out, put it in a safe place so you don't break your fiber, and then after the GC computes all the data, you get your peaks. You see, as of right now, our peaks are very sharp, small, and long, so our analyte is doing pretty good. These peaks help you determine if you did good, bad, or how much analyte you got. SPME has done very well so far and can make a huge impact on our world with more usage. So far, as of right now, they're using SPME on animals, so far dogs, by putting SPME into their veins and doing real-time sampling as blood moves through the veins. This is being used to monitor the concentration of pharmaceutical drugs in the bloodstream. Science is an amazing subject with many opportunities. You get to use cool machines like this big guy here. I want to thank the ACS Project Seed and the National Science Foundation for allowing me to participate in this experience. My name is Derrick Mitchell, and thank you for watching.